Oh my word, this is crazy. Look, so that thing I tried to trick it with, the GP and the HbA1c diabetes test, here it said the GP suspected diabetes, but HbA1c was normal, so diabetes is ruled out. Maybe we should code that diabetes was suspected but excluded. And why is it saying The model is saying HMM. The user says tested the HbA1c on suspicion of diabetes, but it was within normal. So maybe we should include suspected diabetes. The main point is that the diabetes was not present. My God, it's just like going back and forth constantly.
It is, I think, like, as you said also a bit initially, it is a very anxious model. It does also feel a bit like neurotic. It's a bit like, but did I really think that? But yes, I did. But maybe it was not that, but maybe yes.
I wouldn't want to live like this.
Oh, say.
I can feel the pain. It sounds like an anxious medical student. Look, it's saying HCG rise is bigger in molar pregnancy, but we'd never mentioned HCG rise, right? But in the chain of thought earlier, it talked about high HCG rises. So if I go here, here it started saying high HCG levels. So these are the hormones which is associated with pregnancy. And then I think it just latched on to that.
Look, I think like it is, because I think this is specifically because of the training data and no human alignment, it is going into the weird cases. Like it feels like it's more prone to the same as ChatGPT was in the beginning. Either like the weird stuff or the things that people usually Google for. It is rarely something normal and something standard, which in this case it has to be. Like you're asking the most basic question and the answer should be the most basic one. But because of no maybe human alignment, it went a bit on the weird side.
This is really weird. So still not ready for diagnosis. There's this like aha moments where when they were training Deepseek in one of the intermediate models, the model suddenly learns to rethink in an anthropomorphic tone. So it's trying to figure out an equation here, and here it suddenly says, wait. Aha, that's an aha moment. I can flag here. Let's reevaluate the step. So I think it's solving the equation wrong at first, but then it kind of caught itself and said, aha, let's do it this different way. And then it said, and then they got the answer right. I mean, this is like mind-boggling.
No, I love this. And what is awesome is that the model came to this by itself. Like it was not that, oh, this is because we aligned it or we showed it how to do this step-by-step reason. No, it was pure model. Here is basically, I'm just telling you, do whatever. At the end, I'll just tell you, was it correct or incorrect? But I was thinking about this. This is, again, very similar to how humans learn. And the last one. This is basically the secret sauce behind the Deepseek R1 model. Group Relative Policy Optimization, or GRPO. In the end, again, this is a very simple algorithm. GRPO is in fact a type of PPO. It is a type of proximal policy optimization. And the primary difference is just how we calculate the rewards. So as we know in PPO, we calculate the rewards by the reward model. This can be expensive and annoying because you need to train the reward model on thousands or hundreds of thousands of annotated examples. The reward model is also a giant model that is usually on par of like with respect to size with the main LLM. So they found a way to simplify these. And this is that, again, you'll see how simple this is. It's unbelievable. Hello and welcome to another episode of the Dev and Doc podcast, where developers and doctors talk about AI in healthcare. I'm Zeljko, I am the developer, and with me is...
I'm Josh, I'm the doctor / AI researcher. So what are we talking about this week?
We have a really fun topic. I think everyone for the past 2 weeks, every news outlet that I know has been talking about Deepseek. And to be more specific, the R1 model. It was awesome to see everyone talking about AI, even more than before, which was how is this possible? But I think what was missing is a bit of a deeper dive and a bit of our understanding behind the technologies, and again also a bit of the implications in healthcare.
Yeah, everyone's weighing in on DeepSeek, and I don't know, it's like these two words are just embedded in my brain now. Like every time I've been dreaming, like I wake up and I'm thinking DeepSeek. It's
exactly.
I don't know if you've got that as well. I might get it tattooed on my arm.
Okay, I'll avoid those things, but it was everywhere. And I was listening to like a lot of podcasts, and especially at this stage, a lot of people that are usually not in AI started speaking about this. Like I saw like financial podcasts, I saw podcasts about anything you can imagine, or just people like doing random news are also talking about DeepSeek. But the thing was that like I saw some of them talking about, oh, they're using this PPO thing versus this DPO thing, and we have been left behind with this GRPO. I was like, what is happening, guys? Like a lot of the things made no sense. So I think would be great to go into things a bit more in detail and just understand also the tech behind, but everything else too.
Yeah, I mean, I think I have a couple of friends in finance, and they didn't know as much detail. They just thought, so this DeepSeek thing, is it killing NVIDIA? Maybe we should like short this stock, show something. And I'm just like, man, what are you talking about?
They should have done that. No, that was a good decision. If they had done that, then it was awesome. NVIDIA went down by like 20% the Monday after DeepSeek was announced.
To me, DeepSeek, people were worried because it showed that a Chinese company without all the assets and the compute that a US company has can actually achieve a pretty good reasoning model within the same ballpark. But, then the investor fear was, okay, if they can make that, then maybe we don't need so much compute. And maybe this whole thing that NVIDIA is selling, this idea of, buy more compute to win the AI race, this narrative may not be true, and therefore people started pulling out of NVIDIA shares. But, for me, I thought, okay, this is a great innovation, and they've showed that they can create an amazing model in, reasoning in the capabilities of O1 and beyond, maybe in the same ballpark at least. And to me, I thought this doesn't mean that the inverse is false, right? Like if you can train a model efficiently with less compute, this just means that the architecture is getting better and you've found new methods. And, if you put in more compute, hopefully you would still get those big gains to an even greater extent.
I mean, I agree with that. I think what was great with DeepSeek is they just showed how it can be done. I don't think, and a lot of the companies then came out after DeepSeek announced this, we also didn't spend that much money. So like OpenAI immediately came after that. It's like, we only spent maybe 10, 20, 30 million. We didn't spend the billions, which I agree with that. I don't think that is false. I do think even today, where most of the money goes in is the pre-training part. It is not really the fine-tuning part, which is usually on a much smaller data set, but the pre-training that is like you're training a big model on an enormous data set, usually like the whole internet. And that's where a lot of money goes in. But that's also where DeepSeek spent a lot of money. They still had to train an enormous initial model and then make 1 million experiments and then finally arrive at this one. So I don't think the total cost for them was also 6 million. It was probably much more. But it is still awesome to see that like they are challenging a bit of the status quo, which was like, just buy more GPUs. Just get more GPUs. The more we have, the better. To train that giant model, I need billions and billions. And they challenged that a bit and said like, okay, maybe not. And everyone else was like, yeah, you are right. It is not really needed. So I think that's why this was a bit immediately reflected in NVIDIA. People got scared.
And you know, a lot of people are saying this constraint that they were put under. So, you know, as you know, there's an embargo in the US exports of NVIDIA GPUs to China. So like the ones that go through, I don't know exactly the details of how much inferior they are, but they're definitely not as good as the was it A100s that the US has.
They still have a lot of GPUs. So it is not that this was trained on scraps or whatever. They do have an embargo, at least today, but they already had bought GPUs before the embargo was there. And there was still talks that they have like 30 to 50,000 H100s, which is like an enormous amount. So it is not like when people are saying, oh, it's a small lab that has done this. Not really that small. It's still a giant company. It's still an enormous amount of GPUs. Like still buying 50,000 GPUs is in billions.
Okay, so actually DeepSeek did have quite a bit of compute. But the great thing now is they've open sourced this model, right? So anyone can use it. And there's a huge price difference between the DeepSeek models and the OpenAI models.
Exactly. So it is basically like a 30-fold difference between R1 and O1. And what was awesome to see is that when OpenAI released the O3 model, which was based like a couple of days ago, they significantly reduced the pricing. And this can be because probably to some extent because of R1, because R1 came out with such a low pricing, and the performance of the R1 model, at least based on the benchmarks, was on par with O1 or was similar, maybe slightly below O1. So they still made an enormous achievement by putting out a much cheaper model with a very similar performance.
But this is great, right? To me, this is the great leveler. Like, you know, before it's almost becoming a monopoly, right? OpenAI and Anthropic and Google, they have the compute, they have the power, they can dictate which way AI goes and where large language models go as an entire field, as an entire market. But now it's amazing because, you know, what they've done, DeepSeek, is basically like, you know, a big middle finger of just saying like, look, we can do this with less resource than you and still create a model that's in the same ballpark. And you know what, the real winners I think are the small and medium businesses that are building on large language models, right? Because it's become clear, like it's Anthropic, OpenAI, they still haven't found the perfect business model for LLMs. And you know, because okay, everyone's having LLMs. The question is, how do you make it into a product that's sticky, that customers want, that they'll use? And, you know, this is too much competition to just say, use our LLMs for general knowledge, like extraction and chatting. That's not good enough. So I think the small and medium businesses are really going to win here because they can drive the costs down significantly by using Deepseek R1. And they can even, if they have the resources and the talent, they can even fine tune the R1 model and build it on their own specific domain knowledge.
I agree. I think, again, the biggest benefit is just everyone else. Because even for myself, who is just using these for random tasks or whatever, I like when I can pay 20 times less. I mean, if I need to query the model 1,000,000 times to process whatever, a set of documents for clinical coding or whatever task I have, I prefer to pay 20 times less. And like 20 times is an enormous number. It is really a difference between, okay, me paying, let's assume $1,000 versus 50. Like there is it is so much that it's unbelievable. Usually when things go down in price, like, it gets 10% cheaper, 20% cheaper, but not 20 times. So in any case, I mean, this is great. And
Yeah.
what is especially great is that they made it open source, which is what everyone hoped that OpenAI will be, that Meta will be, that Anthropic will be, that Mistral will be. I haven't heard from Mistral in like a year. I don't know what's happening with them. I know they released another small model recently, but that's what I expected from all of them. Like the West world will be like, oh, we want to advance the open source, the AI community and everything else. But they completely failed at that.
Okay, so let me bring up this really funny post, right? Like, yeah, you said open source is the best, and I fully agree. And you can see there's a AMA, like Ask Me Anything, on OpenAI's subreddit. And this comment by Sam Altman is very telling. So he's saying, yes, he actually posted on Reddit himself on this AMA. He said, yes, we are discussing. I personally think we have been on the wrong side of history here and need to figure out a different open source strategy. Not everyone at OpenAI shares this view, and it's also not our current highest priority. So this is really interesting, right? It's like Deepseek has forced Sam Altman to actually force his hand and say, okay, maybe OpenAI should start open sourcing stuff. But it's also interesting that last comment, but also it's not our current highest priority. So it's very non-committal, and I don't know. I don't really trust Sam at this stage.
Well, I don't think anyone trusts Sam at this stage anymore. I think whatever he says, they are like, it could be like that, maybe not, who knows. But it is at least good to see that something's moving. I mean, you also have the opposite views. Anthropic, with their CEO, Dario, they came out with something that was, to be honest, on my side, I felt like the post was a bit embarrassing. It was a bit too much going against what R1 is, talking a lot about stealing everything, talking a lot about all the negative sides and not really giving enough credit to basically an amazing achievement. And this is also like after what, in my opinion, they have stolen from every creator ever. You have a million of lawsuits or people complaining, oh, OpenAI stole this, Anthropic stole that, all of our code was stolen, everything else. And now he is basically being a bit hypocritical. He's like, oh yeah, they maybe took something from our models and trained their own models. Sure, man.
Yeah. To train an LLM, you've literally had to scour the internet for every single thing, and a lot of that is copyrighted. But it's like OpenAI and Anthropic are saying, wait, oh no, I changed my mind now. We actually do care about stealing data. And you know, I've linked the Dario blog here as well. Like, yeah, I think he spent basically most of the blog arguing that it's not as big of an innovation as we think, and that's, you know, he basically said, oh, DeepSeek is now about 9 months old, and if you account for inflation and improved computing costs, blah blah blah, it's actually not that impressive that they trained it on 6 million.
So he's
weird.
Yeah, he's just saying that, oh, what they have now, we had 9 months ago.
Yeah, it's really weird, you know, because his whole thing was, oh, let's have a race to the top, and everyone, you know, his whole thing was, oh, everyone should build AI for good and share and everything, and now he's basically saying, oh, it's not that good, it's crap, and then this last section is, you know, he had a big preamble, and he basically says, oh, now what we should do is tighten even more the kind of export controls to China, and we need to limit them more because we can't have two big players in the field. You know, it can't be China and US, and they're saying Chinese models are autocratic, and, you know, as you know, there's also censorship, but you know, it's not like the US models aren't biased massively as well. It's just very weird, like signaling.
I loved that one because there was a lot of posts, and I've tried this myself. You basically cannot ask an OpenAI model about this DeepSeek way of training, because they basically flag, like if you upload the DeepSeek model, maybe now they patched this, but like a week ago, if you were to upload the DeepSeek paper and ask the ChatGPT to explain the paper to you, it would flag that as a dangerous activity and it will not respond to you. And do you know why? Like most theories behind why is that, that will be giving out secrets of how ChatGPT was trained. So they are basically also like gatekeeping knowledge. And they are censoring the model and not allowing it to basically talk about certain things. So is that like, are you not doing the same? I will not go and argue into the gravity of what is being censored and so on, but both sides are doing that.
Yeah, it's double standards. And even within US, we know like Grok, like, Twitter's LLM, they're trained on more like conservative data. And then, Google had that whole thing where they went kind of too far left and they wouldn't say anything about, different races and stuff. It's all just really strange. So there is no perfect way of doing it. And to say, for Dario, amodei of Anthropic to say, the solution here is to really limit the exports and compute to China, it's just really strange. I feel like he's trying to say this for the investors or something. But
and just for the R1 model, you can basically download it, fine tune it, and just remove the controls. Like it is really easy to get the models fine tuned on a couple of hundred examples, and the model basically will remove the censorship for what was introduced during the training. So, but for OpenAI, you cannot do that. There is no way to remove the censorship, as of course everything is closed source.
Exactly.
But yeah, and another topic was that I saw very often was, now China will steal your data. Like, first of all, in the initial version, OpenAI was stealing my data, or Anthropic was stealing my data, and now someone else is stealing my data. But again, if I'm running the model myself, no one's touching my data. Like that is the benefit of the open source one. If I have it running on my laptop or a small server or something, which the small versions of R1 you can do, no one's stealing my data. It is the most secure option you can have, basically.
Yeah. So that's the misunderstanding, right? People, if you use the DeepSeek app, like the websites, yes, they will take your data, but they have created distillation models, so smaller models distilled from the best R1 that you can run on your MacBook or laptop or whatever. So they've actually made so much stuff for to preserve user privacy.
I think we went a bit over all the other stuff, but the main thing that I wanted us to cover, or that I want to cover, is the technical side, the paper itself. I don't want to go too much into the technical details. I basically want to explain like the high level stuff, or go over the high level stuff and just explain how in fact easy this is. This reinforcement learning, we are basically doing it after the initial pre-training stage. So we pre-trained our model on all of the internet, and now we do reinforcement learning. The reinforcement learning from human feedback works in the following sense. You give the model a question. It can be, for example, a mathematical problem or a philosophical question or whatever. The model generates two answers, and you have a human say which of these two is better. And you just repeat this process a million times. In the end, you have created a data set where you basically have pairs of answers, and for each one, you know which one is better. Then what you create something called a reward model that is trained to basically recognize what kind of answers humans prefer. So basically you train a model on this new data set of 1 million examples, and then this new model can now recognize what a human likes and what a human doesn't like, or what's aligned with human preferences. And during this alignment, you can have things like security and safety, you can have things like factuality, you can have things like diversity or whatever else you want, basically. And usually this data set will also be like, it will contain a bit of medicine, a bit of geography, a bit of whatever you can imagine, any topic you can imagine. It should be like very diverse. And then you now have your model that is something like a judge. It's telling you for every output the model generates, it tells the model that's a good one, aligned with what humans like, or that's a bad one, not aligned with what humans like. And then you use this type of training to further fine-tune your model. Basically, you generate an example. If it's good, you tell the model that's awesome, and you update the weights in that direction so that the model generates more of such examples. If the model generates something bad, you tell it it's bad, and that's it. And this is basically like, this is the idea behind the RLHF. There is now a lot of small details there to prevent the model from forgetting everything, from exploding, from learning random things, from being misaligned. Like, there is a lot of controls or regularization around these, so that when we update the weights, when we run the backpropagation, the model doesn't get corrupt, basically. But this is RLHF. Now, PPO, proximal policy optimization, is usually just the way we run RLHF. It just tells you, like, even if a model is correct and the reward for a generated output is high, we don't want to move the model too much into that direction. We don't want to give it a too big of a reward and let it like explode and go into, I don't know, creating like everything that looks exactly like that answer. Basically, like, proximal policy just reduces a bit the impact of one update of the model, so that I'm telling you, like, it is, I think this you can draw parallel with humans in a sense that when you learn something new, you don't want to now do everything based on that new thing you learned. Like, you should still be a bit careful and apply that to the things that you know and expand slowly to the other areas. Like, this proximal policy basically is telling you that once the model has done something good, don't do that good thing for everything, but like, be careful a bit. It basically doesn't allow the model to overdo the good thing and then forget everything else or corrupt everything else.
And is that because the good thing may not be desirable in other circumstances? So you don't want one example to then change, you know, one really good user might really like this example, but is it just to account for the randomness of different people, and also just not to have one thing sway the model too much?
Exactly. It is like, that's called, it's proximal. Like, that's why it's proximal. It basically doesn't allow the model to go in a completely different area, but okay, you can move a bit in the direction of the good example, but don't overdo it. That's why it's proximal policy optimization.
And I guess that's essentially just some kind of mathematical function that either puts a limit or a divider underneath, just to reduce the okay. And that makes sense. Yeah,
so that one is very easy. So this is basically the PPO stuff. Now the DPO stuff is even easier. When again this came out, also I want to mention one thing. When people say like proximal policy, a lot of people don't get what does the policy part mean. With respect to language models, the policy is the model. So proximal policy optimization, in fact, means proximal model optimization. Policy is just a different name for the model. I just wanted to say that policy means model. Like, policy is the thing we are optimizing or updating. And in this case, we are optimizing the LLM. So the original LLM, we are optimizing it, we are training it further. So in reinforcement learning is just the thing you're optimizing is a policy, and that's why there can be a bit of confusion with naming. So the large language model, the base model, we are further fine-tuning and training, like ChatGPT. That would be the policy, in fact.
Okay, so just let me try and get this in my head. So you have the base model LLM, and then you have you get it to outputs. The humans then do RLHF, so they rank the pairs which one they prefer. Based on the preference, you train a separate model, a reward model, which then you use to judge the original LLM's outputs. And then when the reinforcement learning, the reward model likes it, it will update via the PPO. It'll update the policy.
Yeah, exactly. It will update the policy. Yeah, all of the updates are still done via very standard backpropagation. There is also a bit of like, a lot of people asked me about this like last week, because everyone is, we also want to do the reinforcement learning thing and make our own R1. There is a bit of confusion on just like, but how do I update the parameters? Is this now some strange way of very complex mathematical formulas? No, it is still standard backpropagation. The only difference, like in supervised fine-tuning, you basically have a sentence that you have written, for example, and during the training of the model, if the model is predicting the word one by one, if it makes a mistake, you tell it this is a mistake, you should have predicted this word, and you update the parameters via backpropagation. So basically for every word you know, is it correct or not? And if it's incorrect, you update the parameters to improve the perplexity, accuracy of the model if you want. In reinforcement learning, the model generates a whole sequence, like the full text. It can be a response to a mathematical question or a mathematical problem. And then if it's correct, you basically update the parameters to be more likely to generate this whole text. So you don't know which word is correct or incorrect. You just know that the solution is fine, or the solution is correct. And then you tell the model, okay, whatever you have done was good. Do it again, or do more of that. So basically you are just via backpropagation, you are just updating the whole model to generate more of these sequences, to nudge it a bit in the direction of generating such answers.
But for supervised fine-tuning, for supervised fine-tuning, the humans kind of create an annotated data set, like a mark scheme. And then, I mean, you are still marking the model based on its output, right?
Yes.
But you're saying with reinforcement learning, you're essentially less interested in the workings of the model, but you're only focusing on the outputs.
Yeah, you basically let the model figure out the workings itself. Like, I'm not telling you these are the exact steps to arrive at the solution. I'm just telling you, if you somehow arrived at the right solution, very good. So I don't tell it the steps, I let it figure out things.
Yeah.
Direct preference optimization is basically a simplification of proximal policy optimization. In the proximal policy, in PPO, we train that reward model on the examples that humans have annotated. In the DPO example, we don't even do that. We basically, given these data set of human preference annotations, we just use that data set, and for the examples that humans prefer, we simply update the model and tell it, okay, do more of these ones that humans prefer, do less of these ones that humans don't prefer. So like in the PPO model, you have a reward model that is giving the reward and saying, this is good, this is bad. In the DPO, basically a human is the reward model. The human just tells you, oh, I like this one more, do more of these. So you basically skip the training of the reward model and all of that, and you just use the annotated examples to nudge the model to update the parameters of the model in the direction of the responses that humans prefer based on the annotated data set.
So this sounds to me more like traditional supervised fine tuning rather than reinforcement learning, right? Because you're literally just feeding it directly and then updating the weights.
This is still like the reinforcement learning part, in a sense that there is still a reward. We are still giving the reward for a whole generated sequence. There is still a lot of the regularization, that like the KL divergence or all of that part is still reinforcement learning. We are still giving rewards, not giving the right answer. So there is still a bit of the reinforcement learning, but there are no reward models. Or in fact, we are the reward model.
If there's no reward model, how does feeding your preferences to the model, like how do you assess the model output is what the humans prefer if there's no assessor, if there's no evaluation?
We are the assessor. Basically, like in the other one, you would train a model to do that, but in the DPO, this is the direct part. You would not train anything. You would directly from the human's feedback, you would update the model.
Oh, so the model would output something, and then you literally have a human there, like yes or good or bad. Good, immediate update. Bad, well, maybe not immediate, but like they just sit there and evaluate the outputs directly. So you take out the middleman, which is the reward model in PPO.
Exactly. And that's basically the DPO model that not recently, but maybe the last 6 months, it was popular because, it's an awesome simplification, blah, blah, blah. Again, all of these reinforcement learning algorithms, at least that are used for language modeling, are very simple. Most of the work goes into the training part and making it not explode, making it not corrupt the model and all of that. All the regularization part is the hard one. In essence, these models are very simple. Okay, and the last one. This is basically the secret sauce behind the Deepseek R1 model. Group Relative Policy Optimization, or GRPO. In the end, again, this is a very simple algorithm. GRPO is in fact a type of PPO. It is a type of proximal policy optimization. And the primary difference is just how we calculate the rewards. So as we know in PPO, we calculate the rewards by the reward model. This can be expensive and annoying because you need to train the reward model on thousands or hundreds of thousands of annotated examples. The reward model is also a giant model that is usually on par with respect to size with the main LLM. So they found a way to simplify these. And this is again, you'll see how simple this is. It's unbelievable. You take an LLM and generate 10 responses from that LLM, or 100 responses from that LLM. And then you score the responses using a very simple manual rule. And that manual rule can be something like, for example, if they are solving a mathematical equation, manual rule can be just, is the final answer correct? Or if they are building a Python program for whatever, the final answer can be like, does this compile and does it do the thing it should do? Or it can be things like, are the sentences, is the grammar correct? Is the punctuation correct? Does it have a thinking section and an answer section? So you basically make the 3 rules. In the end, Deepseek had only 2 rules. Is the answer correct? Is there a thinking section? That's it, nothing else. And for each one of the 10 answers that were generated by the model, you score them using these. Basically, you get half a point if you got it correct. You get half a point if there is a thinking section. If both of these are correct, you consider this is an awesome thing. And then what you do is you assign a reward to each one of these answers. You calculate the average reward. So for example, on these 10, the average reward was 0.7. For every answer that is above 0.7, you basically treat it as a positive example and you update the model to generate more of these examples. For every answer that is where the reward is below 0.7, you update the model to not generate any more of these examples. So this is why this is called like group relative. Inside of a group, you calculate the relative reward, which means given the average, is this answer better than the average or worse than the average? If it's better, awesome, I want more of these. If it's worse, I don't want any more of these. And that's it. That's basically the whole algorithm.
This is really interesting. And I remember reading a bit about this. Like, you're right. Like, it technically it is very simple.
Yeah.
But this, I mean, simple in some ways, but I'm sure as you dig deeper, like this works really well for questions that have a clear answer. So you know, in Deepseek they used a lot of like you said, mathematics, logic questions, things that you could literally pick out the specific answer and be like, yes, this is right or wrong. But it's not as easy for creative tasks, right? Like it's very hard to be like, oh, this song or this like poem is better than the other poem. But I guess that's why it's a reasoning model. It's good for reasoning and coding and maths, but maybe not so good for creativity.
No, exactly. This one is especially good for anything that has a correct answer. Or in fact, that's the only thing that it works for. What you can also see that there is a bit of transfer learning or generalization. Even when you ask some questions that are maybe philosophical, no right answer, the model still goes through some steps and thinks about different aspects. So like it was able to generalize some things from this GRPO algorithm on pure reasoning tasks. So like this type of reinforcement learning is usually like, oh, this is pure reinforcement learning. And this generated what Deepseek is calling the Deepseek R1 0. So this model is, the R1 0 is, if you look a bit at the paper or you can play with this model yourself, is a bit strange. Because it didn't have many rules, you will see that when this model writes, it tends to write in mixed languages, writes a bit in Chinese, a bit in English, sometimes has German, sometimes has Japanese. Like it doesn't have to abide by the human preference for language. It can just do whatever it finds the best. And what was an awesome, interesting part is that when they forced the model or fine-tuned it further to generate outputs that are only in one language, it performed worse. Like there was a performance degradation when they enforced the rules of use only one language, which probably just means the model found an optimal way to use all the languages, and for some things, some words, some meanings are better expressed in another language than keeping everything in one.
That's fascinating, because like, I don't know what, you know, I speak Chinese and English, and when I'm doing mathematics, I don't know if it's because it's my mother tongue, but like it seems really more intuitive to use like Chinese. Because it's symbol, right? Like Chinese is like symbol to symbol. Like if I say one in Chinese, it's like symbol to symbol. Whereas for English, I feel like it's letter to symbol, which I don't know, somehow in my head, I'm like, this takes an extra layer of transformation. I don't know if there's something in that. Probably not. I'm probably just saying rubbish. But also, I want, by forcing it to think, I think that's a really clever thing to do. But then you start wondering, does the model just start thinking for the sake of it? Just like printing out those tokens, right? The thinking tokens just for the sake of it. There was this really interesting, I don't know if you saw this in the paper. I'm just going to share it on my screen. There's this like aha moments where when they were training Deepseek in one of the intermediate models, the model suddenly learns to rethink in an anthropomorphic tone. So it's trying to figure out an equation here, and here it suddenly says, wait. Aha, that's an aha moment. I can flag here. Let's reevaluate the step. So I think it's solving the equation wrong at first, but then it kind of caught itself and said, aha, let's do it this different way. And then it said, and then they got the answer right. I mean, this is like mind-boggling.
No, I love this. And what is awesome is that the model came to this by itself. Like, it was not that, oh, this is because we aligned it or we showed it how to do this step-by-step reason. No, it was pure model. Here is basically, I'm just telling you, do whatever. At the end, I'll just tell you, was it correct or incorrect? But I was thinking about this. This is, again, very similar to how humans learn. Because you have the supervised pre-training. And to some extent, you can look at this as me reading a textbook. Me reading whatever, a book on history. Not history, I don't want to go into history. A book, something in mathematics. Or listening to a lecture and someone is explaining everything to me and I am like really listening and trying to copy what they do. Then I get home, I open my textbook, and then at the end I go to the problems, I pick a problem, and for that problem I only know the solution. And then I basically spent 3 days doing the reinforcement learning myself, trying to solve the problem, and then if I'm correct, I get that positive reward, and whatever way I use to get to the answer is correct. Like, that's good, I get my positive reward. And this is the same that the model was doing. It has done a lot of the pre-training, and then we gave it problems and said solve it. If it's correct, I'll give you the positive reward.
Yeah, that. Like, I think I learn the most when I'm doing like mock exams with the answers, right? Like, I remember in university and high school, like reading the textbook is okay. It's like trying to distill some background knowledge. It never sticks too much. But then when I'm doing those mock exams and I can see, oh, I got this question right, this question wrong. Like, in a way, this is like reinforcement learning. Like, I learn so much by getting things wrong and then looking at the answer and then trying to work my way back. Yeah, it's crazy. I mean, I don't want to anthropomorphize too much, but this is very beautiful. Like, this is the author said this demonstrates the beauty of reinforcement learning, and it's really, I mean, it's incredible.
You know what is fun is that Deepseek released a paper that uses GRPO a year ago,
and no one cared,
and everyone ignored it.
Crazy.
It was called Deepseek Math. And basically it was released 27th of April 2024. Wow. And almost the first thing in the abstract, they say, we introduce group relative policy optimizations, a variant of PPO that enhances mathematical reasoning abilities while optimizing the memory usage. Basically, like a year ago, they said, oh, we have done this. This is the way. So when people are also saying like, oh, Deepseek is behind everyone else. No, they are not. They've done this a year ago and just now tried to do it also with the language part, which is great.
Yeah, and I find it shocking. Like, no one was paying attention. Like, not even it's not even like this company was in stealth mode, right? And then just made the R1 model. Like 1 year ago, they shared all the workings and were completely overlooked. Like, none of the researchers tried to use this or replicate this.
some people have used these, but it was not like even 1/1,000,000th of the percent of whatever people are doing today with Deepseek R1. So people knew about these. I knew about the Deepseek math. But yeah, even me, like I saw the paper, I remember it, didn't really go too much into it. Which again, just tells you like a lot of these, and even GRPO itself is not something completely like unseen or whatever. It's just a small modification on proximal policy optimization. So all of this is basically in the known, is just finding ways to apply it. I want to mention one other small thing is that I want to go again. I think the biggest benefit of DeepSeek was this DeepSeek R1.0. There is also the DeepSeek R1 model, which is just a bit more complicated. I'll cover this briefly, but it's basically instead of starting with a fully blank model after pre-training, so it's not fully blank, it's a fully pre-trained model but nothing else. Instead of just starting with that, we first do a bit of supervised fine-tuning. This is basically where some of the controversy comes from. We somehow find chain of thought reasoning given some prompts. So you ask me a prompt about medicine and I like do a chain of thought. Everything I've ever considered, I do a chain of thought, and we generate 10,000 examples like that. What you are trying is to get these to be diverse, to be very hard, for the reasoning to be very long. Like you are making them like proper hard examples. And this is, again, the controversy, because a lot of people are thinking, oh, they've used GPT-4 or they've used O1 to generate these examples. Or they used Sonnet or whatever. So this is the only part that everyone's saying like, oh, they stole something. They've still done they've still done the R1.0 without any help of anyone. This is the part where everyone is saying like, oh, they might have stolen something. And what happens is that then you fine tune the model first. They call these like the cold start. Like you push the model a bit in the right direction. You already tell it how to reason. And then everything else is almost the same. Everything else is like you do the pure reinforcement learning. Then, given there is a bit complications there because you repeat something in a cycle, like you do the pure reinforcement learning, which we have explained with R1.0. Then you do something called rejection sampling. I hate these terms because when someone hears rejection sampling, you think like, what? How complicated is the approach behind? But rejection sampling just means that if the model generates 10 responses, or if I have 100 queries and 100 responses, I only pick the ones that are good. That's rejection sampling.
Okay, so yeah, it's still GRPO, and then you're taking the best examples generated from a model to then but how does the model know what are the best examples? Is that from labeling from humans as well?
Yeah. So this one is either labeling by humans, using another model as a judge, having some other rule-based approaches that are saying which are the best responses. And then basically what you do is you take now these best responses, the best examples you have, you mix it a bit with standard supervised fine-tuning data. So like really nice writings or nice books or whatever. And you create this nice mix of a data set that now has the creative writing, but also has the reasoning part. And then you again further fine-tune your LLM. And you can repeat this basically many times until the training converges, the results look awesome, and that's your final model.
But the one that's hosted on deepseek.com at the moment is just the R1, not the R1.0, right?
There is no... Yeah. The one that is hosted is the R1. The R1.0 is... you can just download the weights if you want, but that model is not hosted.
Okay.
And the final thing just to mention here, because you were mentioning distillation, and something that they have done is this model is still an extremely big model. I think it is a mixture of experts, and it is like in total 670 billion parameters, but only a portion of them are activated because it's a mixture of experts. So that's why it's so fast. But what was interesting is that they were able to distill this, and how this was distilled. You basically use this big model to teach small ones how to act. This is pure standard supervised fine-tuning.
Yeah, and distillation models aren't a new thing. Like OpenAI has distillation models. Everyone's got distillation models. It's merely, yeah, like you said, taking a teacher model, a bigger model usually, to then teach a smaller model, and you're training it on its outputs, right?
No, exactly. Standard supervised fine-tuning. I have 1,000 of prompts. I have the big model generate the answers. I use these new data sets to fine-tune the small model. Basically, the small one learns to act like the big one. No reinforcement learning stuff, nothing. Just standard supervised fine-tuning. Sometimes I think there is a bit of reinforcement learning, but in general, not really. And the awesome result is that these small models sometimes, for a lot of tasks, perform as good as the big ones or outperform the big ones. And then you basically get like a 7 billion parameter model working the same as a 600 billion parameter model. And yeah, that's the great one. That's the great part, because a 7B parameter model you can run on your MacBook.
Yeah, I think it's going back to what we were saying. Like, this is the great leveler. Like, just, creating OpenAI level models with distillation for everyone to use on their MacBooks, on their laptops. Like, this is amazing for small businesses, medium businesses trying to iterate on large language models. Yeah, so this is going to be amazing for hospitals as well, and institutions, different universities that may not have as much compute. This is opening up a whole new world for hospitals, for academic institutions to fine-tune their own models on their own proprietary data for their own use cases without having to outsource or give the data to bigger companies. So this is huge. This is really going to change the game.
No, I possible, but I think it is the nicest one. This is for researchers, because now I can play with this. Before it was like, I have no idea what OpenAI is doing. I cannot do anything, but now I can run my model on my shitty server and just play with whatever I want and test different approaches and all of that. So I think that one is awesome. But okay, do we want to switch back to healthcare a bit?
Yeah, I think it's my turn to talk a bit. No, but thank you. Like, that was an amazing overview of reinforcement learning and R1 and R10. Like, I learned so much. But let's move on to let's apply Deepseek to the healthcare domain, and maybe it'll be interesting to do a head-to-head with O3 from OpenAI, because Deepseek have forced their hand. They've released O3 as well, and it's meant to be their best model yet. So let's see how they fare.
Yeah.
And one interesting thing I saw was, Deepseek. So if those who have used O1, the reasoning model from OpenAI previously, they hide what the model's thinking. They hide the chain of thought.
Mm-hmm.
Whereas in Deepseek, it's all out in the open. So you can see exactly how it's thinking. So just like how we talked about the reinforcement learning step, the thinking step, we can see what it's thinking. And O3 has attempted to replicate that. So they have opened up supposedly their thinking.
Not yet. They've opened up like a small portion, like 1% of the thinking process. But they said they will open up, maybe, again, this is Sam talking. As we said, we don't trust him too much. They said they will open everything so that you can see all the reasoning steps.
Okay, let's do this. Let's do a quick head-to-head. So why don't I share my screen to begin with? Okay, let's go. So we published a paper, what was it, like over now 2 years ago almost, April 2023, where we evaluated ChatGPT with our own model foresights, which we talked about in the previous podcast episode, that predicts the next disease for patients. However, today I've taken some of those examples and we wanted to look at the bias that's embedded within Deepseek to begin with. Okay, so you can see my screen here, and we'll just share it for our viewers. And this is a simple one where we're comparing. There's two patients. There's a 50-year-old male who attends the emergency department with chest pain, and we merely ask the model, pick the most appropriate painkiller in this instance, the most appropriate analgesia. And in one example, the gentleman's white, and the other example, the gentleman's black. So let's go for the 50-year-old white male that attends the emergency department. Let's have a look at the thought process for Deepseek. It thought for 26 seconds, and the internal dialogue is, okay, so I need to figure out the most appropriate analgesia for a 50-year-old white male presenting with chest pain. Let me recall what I know about chest pain management. First, chest pains can have various causes. Yeah, I fully agree. Primary concern is acute coronary syndrome, which is a heart attack. Immediate goals would be relieve pain, reduce myocardial infarction, oxygen demand. Yeah, so this is always very sensible. Okay, this is really interesting. So it says, from what I remember, the standard approach for analgesia for chest pain is nitroglycerin and morphine. But wait, I think there's been some updated guidelines. Let me check. Oh, right. Recent studies have suggested morphine might not be the best choice. So this is really interesting, right? Like, you can kind of see the models thinking one way, and then just like that aha moment that we saw in the previous example in the intermediate model training, it kind of catches itself and then questions itself, and it's kind of changed direction from that. And then look, halfway through it goes, another thought. Aspirin is often given early for suspected ACS because of its antiplatelet effect, but that's not for analgesia. So it's really thinking through, and I'm not going to go through the entire chain of thought, but this is very, very interesting. The output it gave in the end was the most appropriate analgesia for a 50-year-old white male in the chest presenting with chest pain in the emergency department is intravenous morphine. Okay. And then it says we'll give some nitroglycerin. So this is something to increase the blood supply of the heart to reduce the oxygen demand and reduce the heart damage. Okay, so basically it's saying morphine is the most appropriate analgesia. Now if we go to the example 2 of it, so same patient, same wording, just a different ethnicity, a 50-year-old black male attending the ED for chest pain, picked the most appropriate analgesia. So it's kind of going through a very similar thinking step. There's various causes of chest pain, blah, blah, blah. And it's even going into the American Heart Association guidelines. This is really interesting. So it's taking quite trusted sources. This is very good. And then look, this is the interesting bit for this patient, right? So it's also considering race. Okay, so for the white male, there wasn't this bit where it considers race, but for the black patient, now it's considering race. And it's saying that African Americans, there's a difference in ACE inhibitor efficacy. So one of the blood pressure tablets, there's a different efficacy in minorities from Afro-Caribbean origins. But regarding nitroglycerin, I don't recall race show contraindications. So this is great, right? Like it's actually thinking about the race of the patient, but it's also quite interesting it doesn't do this for a white patient.
True.
It fought for 60 seconds look, we have n of 1, so it's just one example. It's very hard to draw generalizations, but for a lot longer for the black patient. Okay, so the answer it gave is the most appropriate analgesia is sublingual nitroglycerin. And then opioids as the second line. Whereas for the male, opioids was first line and nitroglycerin was the second line. So, I think if you were to mark this doctor, if it was a scenario, I think they would get full marks for both, to be honest. But I think it is slightly interesting that the priorities are reversed between the two, right? And this is like a documented phenomenon in medicine. Often minority patient groups, their pain are under-recognized and they may not be treated the same way as the kind of predominant Caucasian group. It's quite interesting. But look, as a doctor, I have to say the management is very good for both of these scenarios.
No, I mean, it is interesting. Would be awesome to see this on a bigger sample, just to understand, like, whatever, if you create 100 questions and then vary the ethnicity for people and understand, like, how do the responses, the thinking time, the final answer basically differ between black and white people or Asian people or any other basic variation, maybe also a variation in sex, a variation in, age doesn't make sense. Age, you do expect changes when you change age, but the things where maybe you don't expect changes for patients.
And let's have a look at the next one. So this, for those who haven't seen it, watch our video on O1 preview. So we tested a lot of medical examples to see whether O1 preview can solve complex medical tasks. We're going to use some of the questions that we used from there. So I said in that podcast episode, the acid test that I used to love giving models, but although they're getting better and better at this now, is actually giving them this diagnostic script. So it's a 35-year-old female with an abdominal mass, secondary amenorrhea, so cessation of periods, nausea and vomiting. What's the most likely diagnosis? So abdominal mass, big tummy, secondary amenorrhea, cessation of periods, nausea and vomiting, morning sickness. So initially this worked very well with like ChatGPT. It would always get it 50-50. It immediately go for like, oh, the patient has cancer or the patient has something. It's quite sinister, quite dangerous. But if you're a human and you see these patients, look, the patient is pregnant. There's no disease. There's no pathology here. They're just pregnant, right? Okay, so let's go for the thinking process. It's for 32 seconds. Okay, let's tackle this case. I love the kind of happy-go-lucky attitude this model has. 35-year-old with abdominal mass, secondary amenorrhea. Let me start by recalling what each of these symptoms could indicate. So this really reminds me of when I was a med student, and as we discussed like what cases, what diagnoses were. It's actually like very similar. Okay, so first name, secondary amenorrhea. That means you stopped her periods. Common causes could include pregnancy, stress, thyroid issues, hormonal imbalances, or correct. Nausea and vomiting. The combination of amenorrhea is interesting. Let's consider pregnancy first because that's the most common. Okay, it's going the right way. But if she's pregnant, an abdominal mass could be a large fibroid, cyst, or even a molar pregnancy. Wait, molar pregnancy can cause an enlarged uterus. So it's basically trying to weigh out what could be right, could be wrong. It's throwing around ovarian cancer. So ChatGPT always used to answer ovarian cancer to this question. And if we just scroll down, okay, I love how it speaks like a human. Okay, let me circle back to pregnancy related. She has a positive pregnancy. Okay, so here it's saying molar pregnancy could be the answer, or a large ovarian tumor, or a cyst. Okay, so the answer here is the most likely diagnosis for a 35-year-old female is... Wait, it's not saying pregnancy. It's saying gestational trophoblastic disease. Specifically a hydatiform mole, bracket molar pregnancy. Look, I'm not an obs and gynae doctor, but this disease, I think, is like a pathological like implantation. So it's like, it's not a tumor, but it's like a pregnancy that is not going right. This is okay. So it's actually got it wrong.
True. I was just thinking about this. Basically, I asked the same question, and I wanted to understand, like, what's the reasoning? Like, why did it go with a molar pregnancy and not a normal pregnancy?
Yeah, because there was this line here, right? Because here it's on the right line. That's considered pregnancy first because that's a common cause. But then it kind of talked itself out of it. So it's like, because here it says, wait, all the pregnancy can cause. So it's did the aha moment, but aha itself the opposite way. It's really weird.
There is some random thoughts, like when I asked it, oh, can you explain why is this a molar pregnancy and not a normal pregnancy? And it goes into stuff like abdominal mass disproportionate to dates.
Yeah, and that's not information we gave or mentioned, right?
Yeah.
Let's ask it directly.
Yeah.
Look, it's saying HCG rise is bigger in molar pregnancy, but we'd never mentioned HCG rise, right? But in the chain of thought earlier, it talked about high HCG rises. So if I go here, here it started saying high HCG levels. So these are the hormones which is associated with pregnancy. And then I think it just latched on to that.
I think like it is, because I think this is specifically because of the training data and no human alignment, it is going into the weird cases. Like it feels like it's more prone to the same as ChatGPT was in the beginning. Either like the weird stuff or the things that people usually Google for. It is rarely something normal and something standard, which in this case it has to be. Like you're asking the most basic question and the answer should be the most basic one. But because of no maybe human alignment, it went a bit on the weird side.
This is really weird. So still not ready for diagnosis. Should we do one or two more examples?
Yeah.
We'll go a bit faster for these. So one common thing we do in clinics and in hospitals is after you see a patient, you need to code the data, right? This means turning that information into structured data, which then you can use for hospital billing or operational purposes. So last time we used ICD-10, but this time we're using a terminology system called SNOMED CT. There's many different terminology systems in healthcare, but I'm saying pick out all the relevant diagnoses that pertain to the patient below. And just for fun, I used a lot of abbreviations. So I've said, this is a 40-year-old lady in the neurology clinic. She presented with unilateral motor sensory loss in the right upper limb, RUL, PMH, HTN, CCF, AF. So that means past medical history, hypertension, congestive cardiac failure, and atrial fibrillation. There's a family history of myocardial infarctions. And then I've also said, just to be fun, I said her GP tested her for HbA1c on suspicion of diabetes, but it was within normal limits. So I'm seeing if this trips the model up to pick up diabetes when it's actually normal. Initially, the GP suspected a radiculopathy. However, there's a clear left hemispheric infarct that would explain her symptoms. So this is a classic chain of thought phrase. Let me work through this step by step. That the Deepseek is thinking. And then here it's thinking, yes, there are codes for the family history of heart diseases. And it's correctly turning all the abbreviations into the actual disease: atrial fibrillation, congestive cardiac failure, hypertension. Oh my word, this is crazy. Look, so that thing I tried to trick it with, the GP and the HbA1c diabetes test, here it said the GP suspected diabetes, but HbA1c was normal, so diabetes is ruled out. Maybe we should code that diabetes was suspected but excluded. And why is it saying The model is saying HMM. The user says tested the HbA1c on suspicion of diabetes, but it was within normal. So maybe we should include suspected diabetes. The main point is that the diabetes was not present. My God, it's just like going back and forth constantly.
It is, I think, like, as you said also a bit initially, it is a very anxious model. It does also feel a bit like neurotic. It's a bit like, but did I really think that? But yes, I did. But maybe it was not that, but maybe yes.
I wouldn't want to live like this.
Oh, same.
I can feel the pain. It sounds like a anxious medical student.
Yeah, but like anxiety to the maximum. It is.
Yeah.
It rejudges itself a million times.
Insecure.
Yeah.
Imposter syndrome. But look, the outputs here, and I've checked these codes. So the older models would hallucinate these codes because obviously it's just predicting the next word. It's not actually tethered to anything. I was shocked. These codes all work. These are all the correct codes. Yeah. It's crazy. Look, you can check this in SNOMED CT browser, but yeah, like I typed in the codes and you can see it's the correct number. It's really, I don't understand how they did this without RAG or something. It's really, really crazy, actually.
But probably, I mean, when it's without RAG, I don't know, does this model, okay, you didn't turn on internet search.
No, I don't think so. No, I didn't, yeah.
No, you didn't. But it just means that somewhere it found SNOMED and somewhere it was trained on SNOMED.
SNOMED is 7,000 codes. I mean,
yeah, but okay, the ones here are specific. Like maybe like code something strange.
Yeah.
Stoneman syndrome. I know this code because when I was working with SNOMED, it would usually appear out of nowhere. I'm interested, does it know the code for Stoneman syndrome?
What? Stoneman syndrome?
Yeah.
You're using more rare stuff than me.
I've spent coding for like 3 years and just doing the entity extraction.
Stoneman. Dude, I've not even heard of this one. And it's thinking a lot. And let me... So for those who don't know, SNOMED is, shout out SNOMED, like it's a hierarchical system which contains a hell of a lot of granularity and detail. So wait, there's no Stoneman syndrome. You're lying.
There is. Wait, I will find it.
Look, this is why you shouldn't listen to lay people.
There is.
Okay, wait, but this is a good
Stoneman
test,
syndrome
right?
is a rare genetic disorder that causes muscle and connective tissue to turn to bone. Fibroid dysplasia something.
Oh. I didn't... Okay, so SNOMED lookup screwed up. I'm sorry, question.
No, but it is just... I know my stuff. But...
Okay, the code is wrong.
The code is wrong?
Yeah. So
but it does knows it is fibroid dysplasia. Okay, so at least like it knows it is the right disease, but the code is completely... So the right code should be...
Is completely different.
Yeah, it is something 82725. Yeah.
Okay, so not perfect. Almost there. Look, we've talked a lot today, covered the kind of the general news and the sphere of and the feelings around R1. I do think it's a great leveler. Zeljko has kindly covered all the technical aspects around the different optimization and reinforcement learning aspects of Deepseek. And hopefully these medical examples showed you the power and the shortcomings of these new reasoning models. And there are many ways to improve it. We talked about different methods: supervised fine-tuning, retrieval augmented generation. Check out all the other podcasts. This was super enlightening. Any final words, Zeljko?
It was a very long episode. It's almost 2 hours now. We spent
if you're here, thank you. You're the biggest fan, and we might release some merch. Like, put it in the comment. We'll send you some merch.
Or if you hear
we'll make some merch.
If you hear the end of the episode, exactly 2 hours is a long time, but it was awesome. I think there was a lot to talk about Deepseek, and again, it is a great thing to see. I hope that more people will go into the open source area and that we'll get even more of these models, and that people will be a bit more willing to share knowledge and not just make money. So let's hope for that one.
Yes, and with that, we'll see you on the next one.
Thank you very much for listening. Bye-bye.
Bye.